Welcome to the last panel of our conference today. And my name is Ludwig Siegler. I'm the US tech editor of The Economist. And part of my job is to follow closely what's happening in the telecoms world. And today we'll be talking about one of the things which I have to think a lot about, technical standards like 5G, and how they can foster innovation. And on the panel, we have two eminent experts who have been deeply involved in the making and the implementation of these standards, in particular 5G. So we have Luis Romero. He is Director General of ETSI, and ETSI stands for the European Telecommunications Standards Institute. And I gather you support kind of the making of standards, kind of part of the global standards infrastructure. And we've also John Smee, who is the global head of wireless research at Qualcomm, which I don't think needs an explanation. So thanks to both of you for being here. And as a tech journalist, I have to admit I'm now in my fourth generation, my fourth G, which kind of dates me. I can still remember in the 80s when 2G was called GSM, Groupe Spécial Mobile, I think was the word. And but I'm kind of still surprised that every 10 years, an industry like the telecoms industry, which is very political and has lots of players and all that, comes together and creates these highly complex standards, and they actually work. And I can take my phone from here to China, and it still works. So, Luis, let's start with you. So how is this happening? And actually, why do we need these standards? And let me be contrarian as we are sometimes at The Economist. Is why do we need the standards? Don't they hold things back? Isn't it better to have more competition?
Well, in fact, that's the usual question. Why do we need the standards? And when you said I can take my phone and go everywhere and still works, that's the reason why you need standards. Bringing all brains together and trying to build something in common that requires a lot of investment, that requires a lot of brains behind. You wouldn't be able to do it without standards. Everybody would be reinventing the wheel, and the only way of achieving such huge investments on such complex systems is by grabbing all this knowledge and putting it together and agreeing on how to move forward.
But walk me through a little bit, not in detail, but what's the process? Kind of how do you start? I mean, people are already talking about 6G. Kind of how do people have to think about how this works?
It's actually quite straightforward because all the companies, and Qualcomm knows very well about it, all the companies can and bring their own, let's say, technologies and R&D and ideas that they share and put on the table. Of course, it's a little bit more complex because you have all the processes and all the architectures needed to put things together, which are being discussed among the experts. And by these contributions brought by all the industry and even governments and operators and all stakeholders that have a say, to build these needs and requirements that then are solved by technological advancements, and that's why and that's how things build together. So all people are building the little blocks and put the plans that put these little blocks together.
Thanks, Luis. John, so Qualcomm is of course an important participant in that process. Tell me, what do you think about standards, kind of, and how does Qualcomm get involved, and how does the firm benefit from standards?
Sure, and to kind of reiterate Luis's point on the importance of that global standardization, it's something where at Qualcomm, when we're driving interesting new approaches, we take a long-term view to how can we enable more people, more industries to be connected. And so as part of our innovation, as we're proving out new designs, bring them to a global standard is a way that after that standardization occurs, then we can have implementations that enable global interoperability. And it also enables more industries to connect. For example, the automotive industry, the industrial industry, the medical industry can all benefit on standards that are enabling, for example, the smartphone industry. So it's an interesting aspect of how that core foundational innovation translated through standards also enables an ecosystem expansion of new business opportunities.
And I mean, but for Qualcomm, I mean, what's the process? So you should propose your ideas how the next standard should work, and then that gets integrated into the standards. But how do you then make money of that?
Well, at Qualcomm, we're always innovating. So we're looking even already now, as mentioned, not only on driving 5G into 5G advanced for that next half of the decade as we look at 2020 to 2030, but also new foundational ideas for 2030 and beyond. So good examples would be bringing advanced techniques, whether it's about leveraging cloud computing or leveraging new approaches to design RAN equipment, or even low latency augmented virtual reality to enable the metaverse. So when we bring new approaches for those designs, we bring them through, for example, the 3GPP standardization body for 5G and R. And in those discussions, there will be certain agreements in the standard of how the transmit signal best accomplishes this high reliability, low latency, very high throughput communications. And then those standardizations enable global participation in the product space for different sorts of designs, ideas, and applications. And at the same time, we're already looking at what comes next for these future products and future opportunities. So I would say the interesting thing then is about calibrating the timeline. So we bring ideas into standards with a pragmatic approach of, what can be implemented 5 years from now. But at the same time, how are we building a foundation for what could be happening 10 years from now? And that's when you bring in terms like forward compatibility. So the investments being made globally on 5G right now, they're still going to be paying dividends in 2030 because it's that foundational fabric of connectivity.
Thanks, John. So, Luis, 5G is currently being rolled out, and if you believe the marketing of the big carriers, it's already done and dusted. All of America is now covered supposedly with 5G, which of course is only partially true. But I mean, where are we in terms of kind of this 5G standard? Is this done, or what can we expect in the next few years?
5G is a continuum. We started 5G a few years ago, and now we are seeing the results in the marketplace. But John was saying, now we are going to 5G advanced, which means it's a continuous evolution of 5G. So we will keep on having new improvements in the technology that will keep on nurturing 5G as we know it today, and we will see more and more advancements as years pass. Probably every 2, 3, 4 years, we are having like new releases, and we expect at least 5G that we will be living with the evolution of 5G. You were talking at the beginning about these decades, so we will be probably speaking about 5G for the next 6 to 8 years. And not only, we still speak about GSM. You were speaking about GSM. GSM was launched in 91, as the first call was in 91. We're celebrating its 30th anniversary, and we still have GSM in the market. So one generation overlaps with the next one, and therefore we will have 5G for a few years still to come.
Yes, John, same question to you. How do you see kind of the evolution of 5G? I mean, right now it seems to be it's mostly 4G, but a bit faster and perhaps a bit better coverage, depending on the network, of course. But what will consumers, what will businesses see, let's say, in 2 or 3 years from now? What will 5G advanced bring us?
Yeah, so as Luis mentioned, 5G is happening in these steps. We call them 3GPP releases. So for example, the first 5G release was release 15, and then we had release 16 that enabled that expansion. For example, connecting vehicles or high designs for low latency, high reliability communications for connecting factories in release 16, combined with time sensitive networking. And then even release 17 is about to finish now in 2021, and that's enabling interesting new applications, whether it's reduced capabilities for IoT connectivity or also taking 5G to even better mobile broadband capacity, coverage, throughput, reliability. And so then heading into 5G advanced, it's about taking that further step, bringing in new approaches. And so if we look at the communications capabilities of 5G relative to 4G, I think one of the game changers is millimeter wave. It's enabling gigabits per second speed, and that's really changing the paradigm on what's happening on wireless versus what used to happen on wired. So take home connectivity or mobile broadband to fixed home access. That's a good example enabled by 5G, where we can now have gigabit per second connectivity to a wider variety of device types. Could be a connected laptop, connected tablet, connected AR, VR goggles, and then also, furthering that digital divide of enabling connectivity into homes so that more people have access to more data. And so when we look at that evolution of 5G and what are the game changers, it's important to understand, I would say, both the revolutionary parts and the evolutionary parts. So we're continuing to make core advances in how we use antennas intelligently with MIMO spatial multiplexing, but at the same time, how we're enabling better coverage, improved transmit efficiency, both on the network side for green energy savings, and then also on the device side so that we can have better connectivity with all-day battery life for consumer applications. So it's this mixture of evolutionary communication enhancements combined with revolutionary new approaches for designing an end-to-end system. And that's what's kind of exciting about 5G. In some sense, we're at a point of inflection where we have 5G significantly in the market, and at the same time, it's expanding into these new industries, new industrial applications, 5G private networks, as well as, for example, smart transportation, smart hospitals, smart schools and factories. So all of those things are evolving at slightly different paces, and it's that continued investment and technology investigation of how do we put the pieces together to derive the most economic value. And so that's kind of the exciting part about the 5G standardization continuing, is it gives chances to bring in new ideas and new approaches that leverage the investments that have already been made.
Thanks, John. So Luis, talking about revolutions, it's always said that 5G was designed with the cloud, the computing cloud in mind. And it seems to be that we're now seeing kind of the first kind of big disruption of 5G, which is kind of not necessarily services, but it's disrupting the telecoms industry. I mean, do you think that wireless networks, 5G and subsequent generations will actually be hosted fully on the cloud?
There's a very big move towards cloudification, and it's very important that the core, what we call the core network, gets more and more flexible and allows more and more development on top of the core. John was talking about many different applications that need to be flexible enough and adaptive enough to support many different sectors. There are many kind of requirements, and it's more and more difficult to imagine the one-size-fits-all model. So going to something which is very flexible, which allows development on top of what we have, which allows innovation all over the place, will be fundamental. And it also goes along with lines of how you grow the network, how you provide support to the network, and how you can provide specific services in very specific areas or to very specific needs. So altogether calls for, again, more flexibility, and this links very well to cloudifying, if I may use the word, the network.
Now, cloudification is one thing being talked about frequently these days in the telecoms industry. OpenRAN is another one. Open Radio Access Network. That's what it stands for. And John is wondering kind of how does that intersect with 5G? It kind of seems, is this a different standard? Is this a competing standard? How do we have to think about that?
Yeah, it's definitely not a competing standard. So when we look at ability to leverage disaggregated RAN, and so the Open RAN, that definition of these interfaces, it enables more splits in the network. So different focus areas, whether it's the lower physical layer, the upper physical layer, or even how we partition the L2, L3 MAC designs. So if we look at the operation of a network and the deployment of a network, disaggregated RAN and enabled by those Open RAN standardizations, and that's also happening both in 3GPP RAN 3, as well as, for example, in ORAN, there is this perspective of how do we enable more participants to have these different cost structures and different deployment models so that we can leverage general purpose hardware where that makes sense. We can leverage advanced radio units or even new approaches for distributed units, leveraging different types of processing architectures. So if we look at the advancements in computer science and the advancements in how technologies are deployed, how software is updated, leveraging cloud-based approaches, then the reason that disaggregated RAN marries well with 5G is because we're at that point, these networks can be deployed in a different way. We can leverage cloud-based computing as well as technologies like virtualization. So when these networks are being designed, deployed, upgraded, and even as Luis mentioned, we still have a lot of 4G networks. So you have that coexistence of 4G and 5G. And even when 6G gets deployed in 2030, it's going to also be coexisting with 5G networks. So this OpenRAN disaggregated RAN opportunity, it represents a new paradigm in how these networks are deployed, such that you can have more interoperability and more players in that ecosystem. And it's also, in my view, enables certain applications. We look at private networks or bringing 5G into a connected hospital, the ability to have different functional splits in where the processing occurs, where the radio units, where's the baseband processing, where's the upper layer processing. You can start having separable deployments that leverage the best opportunities technically to derive that value. So it enables different ways of the technology being deployed, and it's more flexible in a foundational way.
Thanks, John. And now, Luis, let's look a bit to the future and 6G. I mean, of course, that's not going to happen for another 10 years. But what can we expect? I mean, what's there more to invent? I mean, from a consumer's perspective, this already works pretty well. Yeah.
Well, in fact, this is the million-dollar question. I think we are now already talking about what 6G might bring to the table, and we talk about the Internet of Senses, unmanned mobility. We talk about holographic communications, virtual reality a lot, robotics. I mean, you name it. But I think what's more interesting about the Gs, if we look back in history, we have always failed at saying which will be the killer application or applications or use of the different Gs consistently. And there have been wise people coming and proving us wrong and making things that we couldn't even imagine. I think with 6G, it's going to be very much the same. 6G through the standards, we will be able to offer enablers, technology that's accessible to all, at the fingertips of all these clever people that will come and say and see, well, with this I can do, because it's in their needs. So we have all these great ideas that at least that's what we have. But I'm sure that the community, I'm sure that those that will be using 6G will come with more exciting new applications for the technology that will enable them develop all those applications.
And then just to add on to what Luis was saying, yeah, I was just going to add that if we look at how we connect with our devices today, for example, how are people using smartphones today? And even when are they, for example, taking a video call on their smartphone, things they wouldn't have been doing a couple of years ago. And so the notion of how people interact with technology, whether it's computing with connected laptops, we're going to see, in my view, a lot more connected PCs to the cellular network. And we're also going to see new applications leveraging this metaverse for augmented and virtual reality. So in some sense, we view it as this merging of the physical world, where there's more and more device types, with the digital world, where that data is being digitized, and even devices are exchanging information wirelessly. And then we combine that with the virtualization of the physical world. And I think it's going to fundamentally change the human-computer interface. And that connectivity is core to all of it. So that 5G evolution into more connected nodes and more types of network deployments, it goes hand in hand with this ability to leverage communications and the evolution of computing and even the evolution in the way people interact with technology. So I think they combine together to drive these interesting new consumer applications and enterprise applications.
One last question, because we're already out of time. So you both talked about cloudification and how these networks become more and more flexible, and kind of you have slicing and dicing, and you can have special purpose networks. I'm just wondering, as these networks become more virtualized and software defined, why do we still need kind of these big step generational standards? I mean, couldn't we have a much more incremental approach and kind of feed in innovation as it becomes available? Perhaps you start, Luis, but again, we don't have much time left.
And very, very quickly, I think it's not flexibility and standards are not incompatible. On the contrary, I think at the end of the day, you need a solid basis on which to build on top, because otherwise nothing will work. We talk about the internet, but without all the solid foundations that support the internet, we would have no internet. So I think standards will still be needed just because of that, the big investment that needs to bring everything together.
And John, you want to add something to that?
Yeah, I would add that the reason that the Gs evolve in this approximately 10-year cadence, and at Qualcomm, we like to say we're in the G business. And so it's about that global NRE alignment. So the standardization and this 10-year step to the big new foundational release, and at the same time, that incremental release between generations. So we have that big step every 10 years, followed by about 5, 6, or 7 steps every couple of years. And it's that combination of the big step with these evolutionary steps that in some sense makes sure there's that most economic benefit from those investments.
So unfortunately, we're out of time. So thanks, Luis, and thanks, John, for your very interesting comments. Thanks for the audience for listening or watching. And also thanks to the sponsor of this event, Qualcomm. And it's been a long day, so I will keep my closing comments very short. Perhaps 3 points I think we have learned during this event. One is that 5G is not kind of your next G. It's not like 4G. It's basically turning the network, the wireless network, into a platform and enabling all kinds of new services, from virtual reality to, let's say, self-driving cars or smart hospitals and all of that. So think about 5G not necessarily as a network like 2G, but more like a computer platform like Windows or perhaps Amazon Web Services for that matter. The second learning, I think, is that to get to this new world, it'll take time. We've heard from several of the participants that there are still challenges. I mean, Rakuten has built a great, interesting network in Japan, but ORAN is still kind of a challenge for them. And I think we will see that in other deployments like the Dish network in the US. Cloudification will happen, but it will probably happen more slowly. And third of all, 5G is not kind of the end of the journey. There will be others, and we'll be successively and slowly but surely moving into the world where everything will be wirelessly connected and we'll kind of have access to lots of services. We will have more or less ubiquitous connectivity. I mean, that may be not a world everybody will live in, but I think that's where we're moving to. So thanks again for listening, and thanks again for Qualcomm that it has sponsored this event, and hope to see you in 10 years when we will talk about 6G.